Outside of Toronto in Canada is the tiny Crawford Lake. It's a rare body of water known as a meromictic lake. For its small size at roughly 270 meters across, it is deep at 23 meters. That means the sides slope dramatically downwards, and the water at the bottom doesn't mix with the water at the top, making the sediment underneath extraordinarily well preserved. It's this unique quality that attracted scientists in 2023 to dig up a sediment sample from the lake. This core sample contained clues to centuries of human history, and they hoped it would answer a big question. Had humans created such a profound impact on our planet that it had created a new phase in geologic time? Are we now living in what some scientists call the Anthropocene? There is actually an official global body of scientists whose job it is to decide this question, the International Commission on Stratigraphy, or ICS. Phil Gibbard is a part of it.
And our remit is to actually control the stratigraphy of the entire planet, really. That means the entire geological column, starting with the formation of the Earth right up to the present day.
They are the guardians of the geologic calendar of the Earth's 4.6 billion year history. Geologic time has different types of divisions. These are eons that span hundreds of millions of years. Then there are eras, periods, epochs, and stages. We're living here in the roughly 12,000 year Holocene epoch. This is where the Anthropocene would start, not as an era, but an epoch. This system of organization is based in part on the fossil record, which tells the story of huge changes on Earth, like the explosion of animal fossils that mark the start of the Cambrian period. The chemical makeup of rocks can give signals too, like the iridium left behind by the asteroid that wiped out non-avian dinosaurs, which marks the start of the Paleogene period. Or the way the Earth's magnetism is recorded in rock layers that signal major events, like the large volcanic eruption that started the Chattean stage roughly 28 million years ago. It was in the year 2000 that an academic essay proposed the idea of formalizing the Anthropocene.
Its name is two components to it. The anthropos is obviously the human part of it. The scene relates to the fact it would be an epoch of the Cenozoic, which is the last 66 million years since the asteroid impact wiped out the dinosaurs.
The view that we'd moved away from what might be deemed to be the normal conditions of the Holocene into glacial, which is a warm period in the Ice Age, which began 12,000 years ago. And we moved away from that because of the consequence of human activity.
The best rock evidence that exists anywhere in the world to mark a division in time scale is called a golden spike, and scientists stick an actual golden spike in the ground where they find it. That means that while there are numerous fossils for an extinct species called a conodonte around the world from the Ordovician period, a single exceptional one from Newfoundland officially marks the start of the period. If there's ever a question over a boundary, the ICS deploys one of their 15 subcommittees, each of which specializes in a single time period. These subcommittees will set up a working group of scientists from around the world to identify a golden spike.
Phil Gibbard set up the Anthropocene Working Group. So it was set up within the Quaternary Subcommission to assess the possibility of an Anthropocene epoch.
Earl Ellis joined the Anthropocene Working Group in 2009. 2 years later, Colin Waters joined.
The first goal we had was to plough through lots and lots of data sets, publications by many other research groups, to see if there was evidence in geological strata, such as lakes, in the oceans, in peat successions, corals, even cave deposits, where you could record the Anthropocene. And increasingly we saw that there was evidence of changes happening.
The problem is that evidence of human impact on Earth is spread over hundreds, if not thousands of years, and the working group needed to decide when the Anthropocene started. The authors of the 2000 paper had suggested it start at the Industrial Revolution, which not everyone agreed with.
My tendency was more toward the early agricultural transformations of the planet.
But events like the emergence of agriculture took place slowly, and more importantly, regionally.
Agriculture was off the table pretty quickly, And that's also why the Industrial Revolution came off the list.
The group decided they'd have the best chance of convincing the ICS if they focused on the most dramatic moment of change possible.
And so they chose the Great Acceleration because it was considered to be the equivalent of this kind of instantaneous global change.
Great acceleration greatly increased industrialization, which followed upon the Second World War.
Appearance of novel materials. Plastics is probably the most famous of those, going into production and then being dispersed across the planet. Geochemical signals to do with burning of fossil fuels, introduction of artificial fertilizers for agriculture, changing the nitrogen cycle, how humans have increased the rate of extinctions, how we've managed to move so many species of plants and animals across the planet.
Next, the group had to search for their golden spike, the physical sample that best showed a change had occurred. They researched 12 different sites around the world, from coral reefs to peat bogs to ice sheets, which brought them to Crawford Lake. Because of the unique qualities of Crawford Lake, the sample has clear annual rings of sediment layers dating back to the 1300s, where corn dust shows evidence of indigenous agricultural activity. Then thick, nitrogen-rich layers show the arrival of European settlers who logged and farmed the surrounding area. In the 1930s, there's evidence of the Dust Bowl. And around 1950, they found what they were looking for: plutonium from the first hydrogen bomb test.
One of those points of time you can correlate very precisely is the onset of detonations of these nuclear weapons, because they produce a global signal, so you can correlate those across the planet.
All but one of the 12 samples the working group found throughout the world had evidence of nuclear fallout from bomb testing of that era. Nuclear weapons testing isn't necessarily the best evidence for how humans have changed the planet, but it is the clearest, most universal signal they could find.
It's not strange that they chose the nuclear signal because it's a very good signal for the current time in that lake.
In 2023, the Anthropocene Working Group submitted the 12 sites with the Crawford Lake proposal as the golden spike to the Quaternary Subcommittee for a vote. And the voting members rejected it. Many ICS members thought the addition of a roughly 70-year-old epoch at the end of the Holocene was too insignificant relative to the enormity of Earth's geologic history.
We can't see the wood for the trees, you know? In geological terms, something that lasted less than a century would just be a blip, a blink of an eye in a geological record.
Earl Ellis resigned from the working group prior to the vote, partly because he disagreed there had to be a single, narrow definition of the Anthropocene.
The idea that significant transformation of the planet occurred with the onset of the Anthropocene and not before, that was one of my reasons for resigning. The Anthropocene is about understanding that humans are transforming this planet, and that should be the focus, not 1952 and Crawford Lake.
And Colin Waters maintains the Anthropocene's legitimacy.
It's quite amazing how humans have managed to modify the planet so profoundly in less than 70 years. And probably the only equivalent I can think of is the asteroid impact at the end of the Cretaceous that wiped out the non-avian dinosaurs.
The ICS decision doesn't deny that humans have impacted the planet, just that it doesn't yet have a place in geologic time. For now, it's still a term that's found cultural resonance as we grapple with our mark on Earth. If humans are still around in hundreds or thousands of years, maybe our future descendants will have the perspective to identify our species' golden spike. The field of geologic stratigraphy is meant for deciphering the Earth's deep history, millions if not billions of years ago, through the only means available to us, decoding the signs in rock fragments around the world. It's an awkward fit for litigating our modern history. After all, we don't have to look to the rock record to show us the impact humans have had. The evidence for that is abundant.
And it speaks for itself. We don't need to create a break in time to understand that this is the time when humans are transforming the planet.
Thanks for watching. A big part of this story is about how scientists interpret data. And as Vox producers, we're constantly thinking about ways to analyze and visualize data for our stories. If you're interested in learning a skill like data analysis, a great place to start is Brilliant, our sponsor for this video. Brilliant is a learning platform with thousands of interactive lessons that grow your skills of problem solving and critical thinking. And it's designed to help you build real knowledge in just minutes a day. Their courses use real data sets and teach you skills like how to understand probability and how best to visualize a particular piece of data. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/Vox or click the link in the description. You'll also get 20% off an annual premium subscription.